7.3 homework, similar triangles. Let's go over some of these. I got some of these already written out. Write down the definition of similar polygons. Use your notes if you don't have that in your brain. Two polygons are similar if their corresponding angles are congruent and corresponding sides are similar. Actually, if and only if. Write down the definition of congruent polygons. Two polygons are congruent if and only if their corresponding angles and corresponding sides are congruent. Difference between those definitions: similar has corresponding sides proportional, I wrote that down wrong, shame on me, are proportional, and in congruent figures, corresponding sides are congruent. Determine whether each pair of triangles is similar. If they are, explain why. These are similar by the angle-angle similarity. 60 is the same as 60, 30 is the same as 30. That's the angle-angle similarity. Number 4, we don't know anything about the angles, but what about the sides? Well, if you compare the smallest side to the smallest side, it gives you 10.5 over 7. If you compare the medium size to the medium size, it gives you 12 over 8. If you compare the long side to the long side, that gives you 16.5 over 12. Using a calculator, which I don't recommend because it's lazy, but apparently I got lazy on this. If you divide the top by the bottom, you get 1.5, 1.5, and 1.375. They are not all the same. Therefore, the corresponding sides are not proportional. So we were trying to use the side-side-side similarity, but it didn't work. Number 5, these are similar by the side-side-side similarity. Two corresponds to 3, 2 and 3, and 2 and 3, or you could do it 3 and 2. Doesn't matter which one's on top as long as it's all the same triangle. Those ratios are all the same. So by the side-side-side similarity, those two triangles are similar. Number 6, when you start comparing the angles, you got 105 and 105. Those match up. 50 doesn't match up to 25, but maybe it matches up to this angle. So it's hard to tell unless you know what that angle is. So using the angle sum theorem, I went in this first triangle and I said, well, let's call this angle x. If you add up all those angles together, you should get 180. Simplifying it, I ended up getting that this angle was 25 degrees, which means 25 corresponds to 25, 105 corresponds to 105. These two triangles are similar by the angle-angle similarity. All right, let's get into some real problems, like number 7. Find the value of x. We are not told if these are similar or not. We have to know that they're similar for us to be able to do this. So check this: congruent and congruent. Vertical angles. Angle Q and angle S are congruent because they are 90 degrees. All right angles are congruent. So I'm going to redraw this picture over here so that my corresponding sides are in the same positions. Got 90 and one arc. One arc is R, 90 is Q, and P is the angle without any marks. So it says QR is x plus 4. RS is 2x plus 3. QP is 3. TS is 5. Now these two triangles are similar because of the angle-angle similarity. Once again, angle-angle, angle-angle. Two angles of one triangle compared to two angles of another. So now we can make a proportion 2x plus 3 over its corresponding side equals 5 over its corresponding side. We could multiply both sides of the equation by 3 times the sum of x and 4. That's the multiplication property of equality for real numbers. It says we can multiply both sides of an equation by the same thing. X plus 4's cancel on the left, 3's cancel on the right. So we end up with 3 times the sum of 2x and 3 on the left, 5 times the sum of x and 4 on the right. The distributive property of equality gives us 6x plus 9. The distributive property of equality gives us 5x plus 20. If we subtract 5x from both sides, we get x plus 9 equals 20. If we subtract 9 from both sides, we get x equals 11. The direction said find the value of x. We have done so. We are finished. Number 8. It's the same picture. So it's going to be, these are going to be congruent by angle similarity. We're not asked to write that down, but you should know that while you're doing it. So I'm redrawing this picture. This time it says that QR is 3x minus 4. RS is x plus 1. QP is 4. TS is 6. Since the two triangles are similar by the angle-angle similarity, corresponding sides are proportional. So x plus 1 is to 4, as 6 is to 3x minus 4. I'm going to multiply both sides by the product of 4 and 3x minus 4. That is the the multiplication property of equality for real numbers. I can multiply both sides of the equation by the same thing anytime I want. And right now I want. Multiplying and dividing by the same thing cancels. Oh boy, this is treacherous. Let me make sure I wrote down this information right, because this is going to end up being a mess. Did I put the information in the right spot? QR. Okay, here's how I messed up. I apologize. I've got to go clear back to the beginning. I didn't mark the angles right. The right angle is Q. The one arc is R. And P is the one without any marks. I had P and R interchanged. That will get you into lots of trouble real fast. I apologize for that. So QR is 3x minus 4. RS is x plus 1. I got that. QP is 4. TS is 6. This is going to work out better. So it's possible that the last equation I had would have worked in a different situation, and I would have a mess that I had to solve, but my equation wasn't right because my picture wasn't right. 6 over 4 reduces to 3 over 2. I'm going to multiply both sides by 2 and 3x minus 4. That is the multiplication property of equality. It says I can multiply both sides by the same thing anytime I want. On the left, it's going to give me 2 times the sum of x and 1. On the right, 3 times the difference of 3x and 4. Distributing, I get 2x plus 2. On the right, distributing, I get 9x minus 12. If I were to subtract 2x from both sides, if I were to add 12 to both sides and divide by 7, I get x is 2. The directions asked me to find the value of x. Did it. 9. Determine if each pair of triangles is similar. If it is similar, state the reason and find the missing measure. Got to determine something. We got to state something. We got to find something. There's 3 things we're supposed to do. So right away I notice, hey, we got vertical angles. They're congruent. There's no way for me to know anything else about this angle, this angle, this angle, and this angle, because we don't have parallel lines or anything. So I have to compare now 2 and 4 and 3 and 6. I could also compare 2 and 6 and 3 and 4, but that makes less sense. Here's why it makes less sense. Comparing these two numbers, 2 and 3, 2 is smaller, 3 is larger. Comparing 4 and 6, 4 is smaller, 6 is larger. When I compare these, I want to compare the small numbers together and the large numbers together. So I want to know, is 4 over 2 the same as 6 over 3? Of course it is. So since it goes side, angle, side, I'm going to say, yes, they're similar by the SAS similarity. SAS being side, two sides in the included angle. So determine if they're similar. Yes, they are. If they're similar, state the reason I did that. Find the missing measure. So I'm going to go back and I'm going to redraw this triangle. So it's like this other one. And 2 corresponds to 4, so they go in the same spots. 3 corresponds to 6, they go in the same spots. It means we have x over here. This is h, this is y, and this is capital X. So once again, I'm sorry, this is supposed to be a 3. 3, 2. Okay, so 6 compares to 3 as 9 compares to x. So 9 over x is the same as 6 over 3. 6 over 3 is the same as 2. So 9 over x is the same as 2. If you multiply both sides by 2, by x, you're going to get 9 equals 2x, and if you divide by 2, you're going to get 9 halves, which makes sense, because the one triangle is half the size as the other. So 9 cut in half is 9 over 2. Number 10. We got 2 parallel lines cut by a transversal. Corresponding angles have to be congruent. Corresponding angles postulate. Similarly, this is our transversal. This angle and this angle are congruent because they're corresponding. If we wanted to add more information to this, we could say that angle A is congruent to itself. So because of all that information, we know these two triangles are similar by the angle-angle similarity. So yes, by the angle-angle similarity. Then we're supposed to find the value of x. I'm going to redraw this little triangle. ABE with 1.5, 2, and x. I'm going to redraw the big triangle with A, D, C, sad face, smiley face, one arc. So this side here is going to be y plus 1.5. This side's 10. This down here is 6 because 2 plus 4 is 6. To compare two sides, have numbers would be 2 to 6, which is 1/3. That should be equal to 1.5 to y plus 1.5. If I reduce 2 over 3, I'm going to get 1/3. If I multiply both sides by 3 and y plus 1.5, There's not a lot of room here, is there? I apologize for such things. On the left, the 3's cancel. On the right, the y plus 1.5's cancel. We end up with y plus 1.5 equals 3 times 1.5, which is y plus 1.5 equals 4.5. If I subtract 1.5 from both sides, I get y is 3. Now I got to find the value of x. And once again, I didn't give you very much room. Sorry for doing this. So as far as x goes, once again, I could say 2 over 6, which we found out a little bit ago is the same as 1/3, is going to equate to x in 10. I multiply both sides by 10 to get x by itself. I get x is 10/3. Just confirm that that's right. Yep, the answer key says 10/3. All right, number 11. Identify the similar triangles in the figure. So we have to name them by name and put them in the right order. Explain why they are similar and find the missing measure. So we got 3 things to do in this again. Identify, explain, and find. Angle C is congruent to itself. So that means in this triangle we got a 2 arc and a 1 arc. And that means in this triangle we got a 2 arc and a 1 arc. So triangle CDE is similar to triangle CAB. And that's because of the angle-angle similarity. If I were to redraw, well, let's do this one without redrawing it and see if this gives us trouble. Pictures are already drawn with the same orientation, so maybe redrawing it's just not necessary. AC is going to be 39 in length because 15 plus 24 is 39. That's the segment addition postulate. CB is going to be x plus 10 for the segment addition postulate again. So comparing, 15 corresponds to 39. That should be equal to y over 52. 15 over 39 reduces. I can divide the top and bottom by 3 and get 5/13. You don't have to reduce it. I like to. Then I'm going to multiply both sides by 52. Any of you that play cards will know that there are 13 cards of the same suit in a deck of cards, and there are 4 suits. You know what that means? It means 52 divided by 13 is 4. 4 times 5 is 20. Therefore, y is 20. Find the value of x. I'm going to use the same ratio, 15 over 39, which we figured out a little bit ago, reduces to 5/13. That's going to equal 10 over 10 plus x. 10 is this length. 10 plus x is this length. Those are corresponding. We multiply both sides by 13 times the sum of 10 and x. It's a multiplication property of equality. Left, the 13's cancel. On the right, the 10 plus x's cancel. So we get 5 times the sum of 10 and x equals 10 times 13. It's going to be 50 plus 5x equals 130, which means 5x is 80, which means x is, I think that's 16. Yes, it's 16. 2 more problems. Number 12. Now, this definitely needs redrawn. So this angle is the same as itself. That angle is in both this little triangle and it's also in this big triangle. So I'm going to redraw this little triangle. 2 arcs and 1 arc, 3, 4, and x. I'm going to redraw this big triangle so it has the same orientation. Scale, this doesn't matter. 1 arc and 2 arc. In the big triangle, the 1 arc is D, 2 arcs is A, and the unmarked is C. In the small triangle, 2 arcs is A, 1 arc is B, unmarked is E. So what's the length of AD? That's 10. DC is 6. AC is X plus Y. Let's find X first. X is the 10, as 3 is the 6. If I multiply both sides by 10, on the left the 10's cancel, on the right 10 divided by 6 doesn't go evenly, but you can divide them both by 2 and get 3 and 5. I'm going to then multiply both sides by 3, so the 3's cancel on the right. Oh, no, I don't need to do that. Check this out. 3 divided by 3. This ends up giving me x equals 5. Yay! Then in this other equation I can write 3 is the 6, which I could have wrote reduces to a half. Should have done on the last problem, that would have been wise. Equals 4 over x plus y. We know what x is. It's 5. I'm going to multiply both sides by 2 times the sum of 5 and y. On the left, the y's cancel. On the right, the 5 plus y's cancel. This gives me 5 plus y equals 4 times 2. 5 plus y equals 8. Y equals 3. Just check my answer. Yep, 5 and 3. Last one, 13. A 10-foot tree casts a 3-foot shadow. Look at this tree. What a gorgeous looking specimen. Let's say the shadow looks like this. Perhaps not as gorgeous as the tree. A 10-foot tree, so it is 10 feet from the top of the tree to the bottom of the tree. The shadow is 3 feet. The picture is not drawn to scale. How tall is the tree that casts a 22-foot shadow at the same time of day? Well, if we get a 22-foot tree casting a shadow of x length, same time of day, these two triangles are going to be similar because the angle of elevation, which we haven't talked about yet, we will in the future, is going to be the same. And we're assuming that trees grow vertically, so they're perpendicular to the ground. So they're similar by angle. So as far as our fraction goes, we're going to have 10 over 22 equals 3 over x. We can multiply both sides by 22x. On the left, 22's cancel. On the right, the x's cancel. So we end up with 10x equals 33. So x is 33 over 10. It says round to one decimal place, so x is 3.3. Holy cow, I'm way off. What did I do wrong? Well, for one, Okay, I did several things wrong. It says that how tall is the tree? I said it was 22 feet. Eh. The shadow is 22 feet long. Well, that changes everything. My apologies. 10 is to 3 as y is to 22. To get y by itself, multiply both sides by 22. That's going to give us 220 over 3 equals y, which is the exact answer. It says around to one decimal place. This ends up being 73.3 feet. Sentence answer, because it's a word problem, you would write something like, the tree is 73.3 feet tall. That concludes the assignment for 7.3.